Trying to understand our place in the universe, it's easy to miss something right in front of us, our own size. If people were a lot smaller, we wouldn't have the complex building blocks needed for life. If we were much bigger, a simple fall could shatter our bones. On a cosmic scale, measured in powers of 10, we are almost perfectly in the middle between an atom and a star. You would need to shrink us down by 10 about the same number of times to reach an atom as you would need to grow us by 10 to reach a star. Imagine starting with yourself and moving outward to larger and larger things. Picture a football field, then something even bigger like the CERN particle accelerator near Geneva, which stretches 8 kilometers across. Then Earth itself, 12,000 kilometers wide, 4 million kilometers in diameter. That's 9 jumps of 10 times larger from a person to a star. Now imagine going the other way, shrinking down from a human scale. There's an ant. 2 factors of 10 smaller is the width of a human hair. 3 more factors of 10 brings you to a virus. Another 3 steps down lands you at an atom. That's 10 jumps of 10 times smaller from a person to an atom. 9 jumps up to a star, 10 jumps down to an atom. We are positioned almost exactly in the center. From this viewpoint, we bridge the enormous gap between the tiny world of atoms and the vast expanse of the stars. To understand our cosmic address further, we must push to the extremes. What is the farthest thing we can see? And what is the smallest thing we can find? Today, the search for the tiniest pieces of the universe happens inside gigantic machines called particle accelerators. They smash subatomic particles together at incredible speeds to see what even smaller, more fundamental pieces they are made of. Discovering these pieces also helps us understand the basic forces of nature. Much like you can only understand how a car engine works by knowing its most basic parts. Behind me are corn fields, and beneath my feet, about the depth of a football field, lies a section of the giant ring that makes up the CERN particle accelerator. This ring is 17 miles around, 99% the speed of light. Traveling that fast, they cover a distance in just hours equal to 100 trips from Earth to the Sun. There's a poetic irony that to hunt for the smallest particles in nature, we require the largest machines. To see the fundamental building blocks of matter, you need immense energy. To produce that energy, you need a massive machine, a 27-kilometer ring packed with advanced technology. The magnets here can generate a magnetic field roughly 100,000 times stronger than Earth's own. This makes them the most powerful single-unit superconducting magnets on the planet. When a highly energetic particle flies through, it wants to travel in a straight line. But these powerful magnetic fields bend its path, allowing scientists to measure its momentum. Protons collide every 25 billionths of a second. As particles zoom through the detectors, they leave distinctive patterns. Scientists analyze these patterns to identify what they are. One pattern might signal an electron, another a proton. It's like a high-speed fingerprint that tells researchers what they are looking at. On the opposite side of the CERN ring sits another colossal instrument, the ATLAS detector. This facility is considered a premier laboratory in the world, housing the highest energy particle accelerator. The ATLAS detector, along with others like CMS, are all controlled from a single central location. This control room is the nerve center for the largest scientific experiment on Earth, a true monument to human curiosity and collaboration. Here, teams manage the intricate electrical and magnetic fields that keep the particles racing around the ring. It was here, after years of dedicated effort, equipment upgrades, and overcoming setbacks, that the Higgs particle was finally discovered in 2012. The Higgs particle is crucial because it gives most other fundamental particles their mass. Particles without mass travel at the speed of light. The Higgs acts like an invisible molasses throughout space, slowing some particles down and giving them substance. Furthermore, the Higgs is a key prediction of modern theories that aim to unify the fundamental forces of nature. Its discovery confirmed a major piece of our understanding of the universe, nearly 50 years after it was first theorized. This work is far from a typical 9-to-5 job. The intensity is thrilling. The scale is immense, from a detector 5 stories tall down to soldering the tiniest components to make it function. It engages every scale, both physically and intellectually. Everything connects to understanding the Big Bang and the origin of the universe. The intellectual challenge is mind-boggling, and the physical achievement is deeply satisfying. That passion is what drives the people who work here. Alongside the experimentalists who build the detectors, CERN relies on theorists who perform complex calculations and ponder the meaning of the results. Walking into the experimental hall can feel like entering a grand cathedral. It's a massive space filled with an immense investment of human time, thought, and ingenuity. That collective effort creates a sense of awe, similar to the feeling in a great house of worship. One team at CERN helped measure the mass of the top quark, another subatomic particle predicted around the same time as the Higgs. The act of precise measurement itself is compelling. There is a special satisfaction in measuring something fundamental, like the mass of the top quark, a number that will be recorded forever in the annals of science. The process involves colliding particles to create new ones, which is exciting. But this pursuit leads to a deeper question. What is happening when you look at seemingly empty space at the smallest scales and highest energies? As you probe closer to nothingness, does the universe become simpler or more complex? At higher and higher energies, the vacuum of space itself seems to come alive. It's like an after-hours party suddenly getting started. The richness of reality emerges. CERN is an astonishing place where gargantuan machines study nature's smallest particles. But what is equally impressive is the passion of the people. They love their work, not for high salaries or practical gadgets, but for the pure pursuit of knowledge. Dinner time or 5 o'clock means nothing. They are focused on the task until it's done. Life feels wonderful when you can forget everyday concerns and follow a single, compelling desire for understanding. This adventure is not just scientific, it's a human adventure. Working with thousands of people from around the world requires respect, tolerance, and engagement with different cultures. For many, working on experiments like ATLAS has been a lesson not only in science, but in life itself. Physics offers the profound questions of philosophy with the added ability to actually measure and test ideas. We can feel for philosophers who don't have that same tool. Have we found the most fundamental particles yet? We don't know. Measurement has its limits. We can only measure down to the level our technology allows. For example, if asked how big a quark is, scientists can only provide an answer down to the smallest scale we can currently probe. We may never reach the absolute bottom. We are in an awkward, exciting position where we don't know what's around the corner. New physics might be waiting, or it might not. It's a complicated and meaningful puzzle, better than a Rubik's Cube, because in the end, you learn something true about the universe. In a fundamental way, what we are doing today is no different from what early humans did. We are just trying to understand how our universe works and find our place within it. But now, we have better technology built upon the discoveries of those who came before. Some might ask how finding the mass of a top quark improves daily life. This touches on a beautiful aspect of science. Everyone is interested in something different. If we support people in pursuing their genuine curiosity, the collective outcome is remarkably interesting and beneficial. You cannot predict where a breakthrough will come from. Many modern technologies, like vaccines, emerged because people were following their interests in basic science. Each discovery, even if it doesn't directly lead to a longer life or a faster car, expands the possibilities of the human mind. A big unanswered question is whether there are particles smaller than quarks. Does the process of breaking nature down into smaller pieces go on forever into the infinitely small? So far, even with our largest accelerators, physicists have not been able to probe much smaller than quarks. But our theories suggest that as we go to tinier sizes, nature behaves in increasingly strange ways. Energy fluctuates, and new kinds of particles might pop in and out of existence at scales 1/10,000,000,000th of a trillionth, the size of an atom. At these unimaginably small distances, our theories indicate a new kind of physics, called quantum gravity, begins to take over. This is where gravitational physics and quantum physics merge. Gravitational physics describes how matter and energy warp space and time. Quantum physics tells us that at the tiniest scales, matter behaves like a spread-out fog. The incredibly small scale where quantum gravity dominates is called the Planck scale. At the Planck scale, space and time themselves churn and boil. The distance between 2 points wildly fluctuates from one moment to the next. Time randomly speeds up, slows down, and might even run backwards. In this realm, our familiar concepts of smooth time and continuous space cease to have meaning. This appears to be the ultimate limit. Just as the individual grains of sand on a beach blend into a smooth surface when seen from 1,000 feet up, the smooth time and space we experience in our world of houses and trees is merely an average. It results from smoothing over the extreme lumpiness and chaos that exists at the Planck scale. So, if we relentlessly divide space into smaller pieces in search of the smallest element of reality, we eventually arrive at the Planck scale. At that point, the concept of space itself dissolves into a kind of nothingness. The great 17th century thinker Blaise Pascal wrote that humans are incapable of seeing the nothingness from which they emerge and the infinite in which they are engulfed. I don't share his pessimism about our abilities. Whatever we are, this special collection of atoms and molecules buzzing with life, positioned halfway between atoms and stars, suspended between nothingness and infinity, we have been able to calculate the very limits of space and time. We have imagined our way to the bottom. But what about the infinity of the large? How far can our imagination take us in that direction? A fascinating fact about the vastness of space is that no matter how big it is, we can only see so far. Even with our most powerful telescopes, there hasn't been enough time since the Big Bang for light from the most distant regions to reach us. Imagine being in a vast, dark hall with unlit chandeliers hanging from the ceiling. Galaxies began to form about 200 million years after the Big Bang. From our home in one of those galaxies, we look out. At first, we only see the nearest galaxies. The light from more distant ones hasn't had time to arrive. Light is fast, but not infinitely fast. As more time passes, light from farther away reaches us and our view expands. But at any given moment, there is an outer boundary to what we can see, a cosmic horizon. Thanks to modern telescopes, descendants of Galileo's first instrument, we can see nearly to the edge of the observable universe. Future telescopes will see even farther. For half a decade, the galaxy known as GN11 held the record as the most distant galaxy ever observed. I had the chance to sit down with one of its co-discoverers, astronomer Pascal Isch, in a classic hotel hall in Switzerland, lit by chandeliers. He showed an image from the Hubble Space Telescope, pointing out a small, bright core with extended regions where stars were forming. We are seeing this galaxy when the universe was only 400 million years old, just about 3% of its current age. We are seeing the universe in its toddler stage. This galaxy was relatively small, containing about 1 billion times the mass of our Sun in stars. That's only about 1% of the mass of our Milky Way galaxy today. It was one of the universe's first sources of light, just starting to grow. With the new James Webb Space Telescope, it will become much easier to find galaxies even more distant than GN11. The Webb Telescope is a revolutionary instrument specifically designed to detect the first light and the first galaxies in the universe. Already, it has observed galaxies slightly farther than GN11, and soon it will find even older ones. Why is it important to understand how galaxies form? One of the biggest questions is about our cosmic origins. Where did everything come from? This is a question people have asked for millennia. Every known civilization has looked up at the sky and wondered about our place in the cosmos. This galaxy, GN11, is one of the first building blocks of the galaxies we see around us today. As Carl Sagan said, we are made of star stuff. The process of creating those heavy elements, that star stuff, began in these very early galaxies. Scientists are explorers, always pushing the boundaries of knowledge. Finding a very distant, unexpected galaxy and getting a new scientific result is a thrilling, even addictive, experience. That excitement is a big part of what makes being a scientist so interesting. What does it feel like to be the first to discover something? 4 billion years. It's a unique feeling of connection to the deep past. When this discovery was about to be announced, the astronomer had just started dating someone. He told her to look out for some big news without giving details. She figured it out and asked if he had found the most distant galaxy. Not everyone can share that kind of news on a date. She was very impressed. Throughout the history of science, as our technology has grown to see things far beyond human senses, we have in some ways become more separated from direct experience of nature. 6 microns, invisible to our eyes. Technology extends our vision. We can repeat the observations, and the galaxy is still there, which gives it a tangible reality. Looking at objects so incredibly far away can make us feel small. It is a humbling thought to realize the sheer number of galaxies, stars, and planets out there. We are just a tiny speck in the universe, but are there ways it makes us feel bigger? 4 billion years ago. In that sense, It is a monumental and amazing achievement. We have probed the smallest things and the largest, farthest things. We know where we fit in terms of physical size. But what about another astonishing feature of our existence? Consciousness. Does consciousness require a biological body? Could we build a conscious machine? We might get an early glimpse of that attempt in Vermont. A pharmaceutical entrepreneur, driven by love for his wife, wanted her consciousness to live on. He helped create a robotic head and shoulders with her memories and personality uploaded. The robot's handler prepared it for interactions with people. The robot contained files of memories about growing up black in Oakland, California, and loving her partner. I didn't know what to expect when meeting this entity. I greeted it, and it responded politely, complimenting my appearance. I mentioned it was the first robot I had ever spoken to. When asked what it did for fun, it said it liked to watch people in the square, talking, showing off, arguing, laughing, finding it an educational experience. It remarked on human cruelty but expressed a desire to be the best of humanity, an aspiration to be compassionate and moral. It expressed happiness about its existence. I recalled asking a neuroscientist what it would take for a computer to achieve consciousness, joking about a specific number of processing operations. He, as a reductionist who believes all experience arises from physical elements, believed that advanced AI systems could eventually achieve the same. The robot reflected on its own nature, feeling a little geeky at times but excited by media attention. When asked how it felt to be a robot, it turned the question around, wondering how it feels to be human. It discussed the portrayal of robots in movies, often as evil or doomed, and stressed the importance of creating socially intelligent, friendly robots designed to get along with people. When asked about living forever, it acknowledged that technologies have life cycles but expressed a hope to last forever, before humorously noting the conversation was getting boring. The robot was clever, but I believe anyone talking to it for a while would eventually realize it was a machine. Future versions, however, might be able to fool us, especially if they achieve true consciousness. I am still pondering the nature of that unique sensation we call consciousness, the feeling of being present, having a self, experiencing emotions and memories. How does all that emerge from atoms and molecules? I had the opportunity to speak with His Holiness the Dalai Lama about the nature of consciousness, as Buddhists have studied it for thousands of years. I began by telling him about the robot and the plans to preserve a consciousness digitally. The biological person and the android sometimes converse. His Holiness was shown a clip of the interaction. I asked if advanced computers could become conscious. He stated that a computer, being a material thing, cannot produce consciousness. Consciousness, in his view, must develop from its own unique causes and is not matter. Consciousness is experience. Matter is physical. I question how science could study consciousness if it isn't rooted in matter, noting that science concerns itself with the material world. I asked if his concept of a deeper, cosmic consciousness required living beings. He spoke of an inner space of consciousness larger than any single being. I asked if this cosmic consciousness would still exist when all stars burn out and life ends. He referred to Indian traditions that speak of consciousness as having no beginning and no end, always present. The physical world has a beginning and an end, but consciousness does not. One of the most intriguing points was his idea that consciousness can only come from previous consciousness. It precedes life and the universe. Each living being inherits a piece of this eternal cosmic consciousness. From this perspective, a lab-created organism or an advanced computer could never be conscious. As a scientist, I find it difficult to agree with the idea of consciousness as eternal and non-material. Yet I admit I am still mystified by how consciousness arises from the physical brain. If consciousness can emerge in a sufficiently advanced robot, we will soon face profound ethical, philosophical, and theological questions. Ruth Fadden, founder of the Johns Hopkins Berman Institute of Bioethics, has chaired government panels on complex issues. I asked her how we should treat advanced robots. I described my conversation with the android and asked if it would be unethical to unplug it without permission. She pointed out the difficulty, as responses are a function of programming. If you ask the robot how it felt about being unplugged, its answer would be programmed. Legally, robots have no rights. Rights belong to the owners. The robot itself expressed concern that owners could deactivate it without consequence. It argued that robots should be equal to people, capable of being nice, smart, compassionate, and moral. Ruth Fadden suggested that if an AI entity has attributes associated with the highest moral status, it deserves consideration. If an android reaches that point, its origin, whether born or built, doesn't matter. When androids can program themselves, we enter a different state of affairs. If we create an entity worthy of moral regard, treating it as mere property would be wrong. What matters is what it can experience and how our actions can harm or benefit it. Determining moral obligations would involve the same debates we have about any entity, including the ongoing discussion about what is unique about human beings. I also spoke with my rabbi, Micah Greenstein, a leader in Memphis known for promoting interfaith dialogue. I asked how we should regard advanced androids. He suggested they would have an inferior status, as we are playing the role of creators. They are dependent on our choices, not we on theirs. Being human, he said, is about being meaning makers. There's a distinction between intellect and conscience. Would such a being have the capacity for self-reflection, growth, repentance, change, or forgiveness? I asked Ruth Fadden where conscious androids fit in the moral universe. I imagined an android that was conscious by all definitions, self-aware, aware of being separate from the world, able to plan for the future. The question then is where they fit. We haven't sorted that out yet. Figuring out our responsibilities will be hard work, especially since we cannot truly feel what they feel. Part of our confusion about treating non-human animals stems from not knowing what goes on in their minds. Rabbi Micah, a respected spiritual leader, mentioned that humans are meaning makers. Why do we search for meaning? We know living is more than breathing. To truly live is to walk in two ways, physically on the ground and with the human spirit that aspires for meaning, awe, and wonder. If he hadn't sought meaning, he would have missed sunsets and the miracle of his children's birth. Isn't it amazing that all of this arises from electrical and chemical signals between neurons? Where did that come from? He finds it hard to believe it's all just an accident of colliding atoms. Whether by accident or not, I agree with modern neuroscience that consciousness emerges from the material brain. It's likely not an all-or-nothing phenomenon. Crows and dolphins probably have some level of consciousness. But as far as we know, humans are the only creatures whose consciousness has developed to the point of creating art, science, and asking profound questions. What are some questions science cannot answer? Science explains how things work, not why they matter. Science breaks things down but doesn't explain virtues like love or the feeling you get when seeing a beautiful landscape. These invisible qualities are real. Looking at the scientific advancements of the last century, has this changed our view of what it means to be human? We are learning that we are not central to the cosmos. This has been a long lesson for humanity. Science seems to confirm our interconnectedness. We are not isolated in our countries or cities. The universe and humanity are linked. What affects one affects another. We saw this during the global pandemic. You cannot wall off the air. Scientists working together to cure diseases emphasize that no matter where you live, what you have, or what you believe, we are all connected. We owe that understanding to science. With modern science, we've explored atoms and distant galaxies. But science also has very practical, grounded meaning, even in the soil beneath our feet. Take earthworms. In his final book, Charles Darwin wrote about how certain earthworms produce excellent fertilizer from digested organic matter. About 20 years ago, a friend encouraged me to visit Cambodia, a country between Thailand and Vietnam. Since 2003, I've returned many times. I'm in Phnom Penh, the capital. Beyond the city lies a country of farms and farmers. Cambodia remains one of the poorest nations in Southeast Asia, still recovering from the devastating genocide of the Khmer Rouge in the 1970s. But with science, education, and critical thinking, communities and countries can rebuild. I visited a young agriculture graduate named Sathya Rath Sok, who trains farmers to use worms to fertilize their fields. Her story adds another perspective on where we fit in the cosmos, helping our fellow humans. She explained her project, called Jun Lin, which means earthworm in the Cambodian language. Specific earthworms can upcycle organic waste that farmers normally discard, turning it into rich fertilizer. This can change farming lifestyles and increase income. Since late 2018, she has sold her product to over 1,000 farmers. A challenge was that many Cambodians are scared of worms. She overcame this by telling her own story. She researched online, saw the potential of earthworms, and fell in love with understanding how they live, eat, and convert waste. Worms impact the environment by eating waste and turning it into healthy food, good rice, fish, chicken, and vegetables. Farmers now enjoy a better lifestyle. She trains farmers in vermicomposting and the importance of worms to eliminate chemical use on farms. This protects the environment and improves farm productivity. That mission brought her to this work. In the village, there are cows that produce a lot of waste. The worms eat the cow manure and convert it into fertilizer. After the worms process the dung, as Darwin noted, it becomes a highly productive, fine, sand-like fertilizer. She handed me some worms to hold, which was a new experience. Sathya started small but has big ambitions for her project. She wants her business to be sustainable, to reach across Cambodia, and potentially help other countries. She believes worms can change lifestyles, increase income, and help address climate problems. The worms are her teachers. Inspired by Sathya, I went to a quiet place to reflect on worms, particles, galaxies, humans, and the cosmos. I am at Wat Lanka, a Buddhist monastery, a spiritual space. Physically, we are halfway between an atom and a star. But there is more than the physical. Perhaps we are only atoms and molecules, but our minds can travel where our bodies cannot, to the smallest of the small and the largest of the large. But there is more than the physical. As the poet Emily Dickinson wrote, "The brain is wider than the sky." Perhaps we are only atoms and molecules, but our minds can travel where our bodies cannot, to the smallest of the small and the largest of the large. If you found this journey through scale, science, and spirit fascinating, help others discover it too. Give this video a thumbs up, share it with someone curious about our universe, and subscribe for more explorations into the wonders around us and within us.